We're here to solve this Yajilin by Joseph Howard called pairs. You'll notice there are 3 clues that both point downwards, 2 clues that both point to the left, and 2 clues that both point to the right. So a little bit of an elegant connection of these clues, although you can see from the pattern in the grid that this is probably a mostly logical theme, not as much a visual theme. But in thinking through the aspects of the logical theme, these 2 columns with 3 downs look to be the first place I want to focus. And in part, that's recognizing that in any adjacent columns, we can never shade 3 cells in a 2 by 3 block. We'll end up making a dead end like this, where the loop would come into the cell but couldn't come out from the cell. And so there are constraints about how many cells you can shade in any of these spaces. And it's even the case on these 2 ends of the columns that I can shade at most one of the cells in these 2 by 2 green blocks. So I could shade this on the extreme, which looks okay, but that now means this cell and this cell can't be shaded, and this cell would also form a dead end if it were shaded. So I can form a single cell of these, but no more. And so that means I've got one cell potentially at most in green up top, a second cell in green down here, which means I need to have 4 more shaded in this space in blue. But if 3 of those were in this top group, they would form an invalid pattern, as we said at the start. So I can get 2 cells here and 2 cells here, but I can't put any in the middle. And that actually means I can't put shaded cells in these green spots, because again, I've got to dodge a 2 by 3 square needing to have 3 shaded cells. And so I can get 1 plus 2 plus 2 plus 1 with these forced gaps between them as one of the first deductions in the grid. I don't know more than that. I've got these 6 cells shaded, but maybe there's a little bit more I actually do know. If you've seen this pattern before, there are places where we actually have to have an alternation of the colors as we shade through, an alternation of the positions, I guess I should say, as we shade down. And so when this cell is shaded, it is very bad to shade these together because we're putting a lot in the same space in a checkerboard sense of colors in the same shaded spot. And this actually is, hopefully you can see, immediately invalid because you're forming a junction here which has to split to the left through this channel, up to this channel, and down to this channel. And the reason it's got to do all this is a cell in the color of the same shaded spaces on a checkerboard, but is forced now to come to this opposite color in 3 different directions because of the touching. And so instead, if this left cell were shaded, we've got to do this pattern, which then extends down here, still this pattern, and even down here to this pattern. And so this is one of the 2 valid shadings for the whole column. And the other is this, which again alternates along the pattern of checkerboard parodies as you come into these different groups. And so these are some of the subtle constraints that make the Yajilin hard until you learn to spot them. So hopefully some of that visualization helps you understand how these columns go. There's a different kind of visualization that I think will be key, and let me set this up a little better than I'm doing now. I've got a 1 right clue here and a 1 right clue here, and they're going to shade one of these cells and one of those cells. But the main thing I want to think about is how this lower right corner right now looks like it could get a total of 3 ends into it. I could come in this channel, I could come in this channel, or I have a single end that can come down this channel. I don't know if it's going to be here or here, but recognize based on that 1 right clue, there's always an end coming down here. And so I really have an either or choice. I can come from the top or I can come from the bottom, but I can't come from both because I can end up with an odd number of ends in this lower right corner, and 2 could join together, but I'd end up with a loose end and an invalid solution in the grid. And how that triggers in is actually if this cell is shaded, this cell forces you to come in with 2 more ends into this lower right corner and quickly breaks the grid. And so it may not be obvious why this cell is bad until you think about loop parity. Loop parity is the second key constraint. After you spot these 3 columns, I think the only other thing you really need to spot on this grid is that this cell is the only one that can be shaded there. And in doing that, we get a space where we'll see that we've got a forcing of this 1 right clue to be in the cell. The other one would close off the loop too quickly, get this in and the cell shaded, so we've taken 1 end and 1 end. Marking that in, we now actually intersect the pattern we'd set up before. So you know for sure this is shaded, and we'll just work through, because we talked through it before, what we know about the other shadings that are going to come up the space. This loop end needs to dodge the 1 right near it, so it comes over this way. We've got 1, 2, 3, 4, 5, 6, 7 ends. I guess one of these, but not both of these, turns in is what that's telling me, where I've got 7 over on the side. And one thing that will help me out is to think through this 2 to the left. It can't take this cell, but I'm going to shade one of these and one of these. And one of the things to note is if I shade this outer cell here, I'm going to close off these ends, but have something that's free and not able to come. So I need to get a fourth end into the space, which looks like this. That actually closes this off, and so that means this end, which would be an even number if it comes to the left, has to come to the left. So I have 6 over here. Came to the right, we'd have another issue with the loop. So we put those in the grid. These ends have to dodge each other, so we've got to have a channel coming down here with a free end. And this end, that now actually makes this cell impossible to shade because we'd isolate here, so we can put this in. These ends are dodging each other as they come up. That comes across. We've got to get 2 ends to the left through the shaded space. I can't shade both of those because we'll isolate a cell. So I do have to shade the cell over on the far side. I have these ends connecting up, so they've got to dodge and join in here. In this upper right corner, I haven't looked at this yet. You can actually do this very soon. At the start of the puzzle, we're going to have an end come into this corner, another end come into this corner, and just based on how the coloring goes, we can put these into the grid, but we're now left with 1 of 2 cells to shade. Notice if I shade this cell, I'm going to isolate this cell in a way that we can't fill in with loop ends, so I got to shade the one down below it. This end and this end connect, so they never reach this cell. This end and this end connects, they never reach this cell, so we shade that in. And then in marking off the remaining things that are forced, we reach the end of the puzzle. So it's a tricky Yajilin pattern that really involved 2 kinds of deductions that are sort of worthy for this being a Thursday puzzle. One was seeing how these 3 down clues work together and made a particular arrangement of either or patterns with some gaps in the middle as a forced start. And the other was seeing how a space like this lower right corner, which has 3 places for a loop end to come into it, can only take 2 of those. And so there was an elimination you can make there based on the available loop end entries to get an acceptable parity of 2 loop ends, but not 3 loop ends in here. So that was a bit of a walkthrough for this whole grid. Hope you learned something about how to visualize Yajilin puzzles, particularly how to see some of the unanticipated constraints when you shade in some of these sections like we talked about with the green-blue coloring. And we'll see you again soon.